Hi guys. Right now we are going to review the answers that we did not go over on last night's flipped video. So go ahead and look at number 2. It says the sum of 3 consecutive integers is 72. Write and solve an equation to find the integers. Now, when we talk about consecutive integers, we always put the first integer as x, and then the following integers are plus 1, plus 2, plus 3, and so on. There are 3 integers, so we've got x as our first, x plus 1 as our second, and x plus 2 as our third. Now, the next thing that I needed to do was set up an equation. Now, on a test or entrance slip, the equation is an important part of me assessing you. So basically, you need the equation correct and the correct answer in order to earn a 3. If you just have the answer, you can't get more than a 2 because I need you to write an equation, show me that you know how to solve it, and then get the answer through that. So let's go ahead and move on from here. We've got some terms that are like, so we've got 3x and then plus 3 equals 72. Subtract 3 from both sides. Unfortunately, using my keyboard, I can't show division, so divide by 3, and then you get x equals 23. Now that's not the final answer because it says write and solve the equation to find the integers. So we need to find all of them. It would be 23, 24, 25. Now, to check my work, if I add 23 plus 24 plus 25, I do get 72, so I know it works. Okay, on to the next question. The sum of 4 consecutive odd integers is 216. Write and solve an equation to find the integers. Now, the key word here is odd. Now, think about odd numbers. For example, 13, 15, and 17. They are all 2 apart from each other. Or 21, 23, 25. They are all 2 apart from each other. Any type of odd number is going to be 2 away from each other. Even though 2 is an even number, odds go up by 2s. So x is our first. X plus 2, because whatever the first odd number is, let's say it was 11, 2 more would be 13. So x plus 2 is the second odd, then plus 4, then plus 6. And so we write out our equation and then simplify it. I subtract 12 from both sides. That cancels off the 12. Then I would divide by 4 on both sides. 4 divided by 4 is 1, so I've got 1x equals 51. And of course, that is not my final answer. I need to find all 4 integers. So my answer is 51, 53, 55, and 57. And the really nice thing about consecutive integer problems is that you can go back and check your work. If you add those 4 digits up and it's not 216, then you know you got the wrong answer. But in this case, if you add them, you do get 216, so we know we have the right answer. Okay, number 6, we started this together, but let's review it really briefly. So basically on the video last night, what you learned is that Melissa is 24 years younger than Joyce, and because we know something about Melissa, it's smarter to use Joyce, the really mysterious person, as x. So we've got x as Joyce, Melissa is 24 years younger, so x minus 24 is Melissa. And then it talks about in 2 years. So we're going to talk about their ages 2 years from now. In 2 years, everybody gets 2 years older. So x plus 2 is Joyce in 2 years. X minus 24 plus 2 was originally what Melissa was, but negative 24 plus 2 is negative 22. So that's the simplified version right there. Now it says in 2 years, Joyce will be 3 times as old as Melissa. So Joyce, which is this, will be. Now the phrase will be is the same as is or was. It's an equal sign. If I say 2 plus 2 will be 4, that's an equal sign in between there. So Joyce is what I underlined in red. Will be is the equal sign. 3 times, so I've got to say times 3. 3 times as old as Melissa will be then. So that's as old as Melissa will be then and 3 times it. Okay, so now I need to go ahead and solve. So I'm going to have to simplify my right-hand side before I can move any variables or anything around. So x plus 2 equals 3x minus 66. And then I like to move the lighter variable, as I call it. I like to move the one that will keep the variables positive. So x minus x is canceled out. 2 equals 2x minus 66. Now the reason that I needed to subtract x from both sides is because I had variables on both sides, and I cannot operate unless I have variables all gathered on one side. Okay, so now I've got 2x minus 66. I need to get x alone. That's my ultimate goal. So I'm going to use SADMAG, subtract or add first. So I'm going to add 66. And then 2 plus 66 is 68. Oops, sorry about that. Equals 2x. I divide by 2. And I get 34 equals x. Now, let's go back and look at our variable definitions. 34 equals x. X was Joyce's current age. So I know when the question says how old are they now, Joyce is 34, and then Melissa is 24 years younger. Melissa was x minus 24, which we see right here. So Melissa must be 10. Now let's go ahead and check this. It says that in 2 years, Joyce will be 3 times as old as Melissa. Let's think about Joyce. In 2 years, she's going to be 36. In 2 years, Melissa will be 12, and that is 3 times older, so that does work. Okay, last problem. I know this one was a tricky one, but if you read it carefully, it's actually not too bad. Tom is 4 years older than Jerry, so we know Jerry is our more mysterious person. We're going to use him as X. 9 years ago, Tom was 5 times as old as Jerry was then. How old is each now? So again, I always recommend figure out who's more mysterious. In this case, it's Jerry. We know something about Tom. So Jerry's going to be my X. This is Jerry's current age. Tom is 4 years older than Jerry. So if Jerry's X, Tom is X plus 4. That's Tom's current age. 9 years ago. So we're going to have to subtract 9 years off to talk about Jerry 9 years ago, and subtract 9 years off to talk about Tom 9 years ago. So we've got X minus 9 for Jerry 9 years ago, and we've got X plus 4 minus 9 is Tom 5 years ago. No, that's not a simplified expression, so let's go ahead and simplify it. X, oops, sorry about that. X minus 5 is Tom 9 years ago. That's the better expression to use because it gives us a chance to realize that 4 minus 9 is negative 5. Okay, so basically now we need to figure out what we're doing here. 9 years ago, so I know I'm using my 9 years ago expressions, this one and this one for Tom and for Jerry. 9 years ago, Tom was, okay, Tom 9 years ago was this, X minus 5. Tom was, just like in the last problem, is the same as is. It's an equal sign. If I say I found out that 2 plus 3 was 5, that's an equal sign. So Tom is in the blue, X minus 5, was is an equal sign. 5 times as old as Jerry. So 5 times, I'm going to need to say times 5. So 5 times as old as Jerry. Now Jerry was this age at that time, so X minus 9. Now, I know that when we go through it together, you're probably like, oh, duh, this seems so easy, but how do I figure it out on my own? Here's what I want you to think about. If you need to draw yourself a little picture, sometimes that helps. Tom is older than Jerry, so I'm going to draw Tom, and I'm going to make him look taller, just because he's older. Okay, there's Tom. He's older than Jerry. I'm going to make Jerry look really little. And so that's Tom, and that's Jerry. Now, if I say Tom was 5 times as old, I'm not going to multiply Tom by 5, because then that's just going to make him super old with white hair. I'm kind of erasing his hair here. He's going bald because he's way too old. We don't want to make Tom any older. We're saying that Jerry times 5 would be equal to Tom. Think about it like this. I'm 28 right now. Mrs. Hogan is 28 currently. Think about an 8th grader who is 14 years old. So we'll think about an 8th grader. Any 8th grader in your mind, go ahead and pick one. That's the 8th grader. And then here's me. Okay? I am twice as old as the 8th grader because the 8th grader is 14. You're not going to double my age because then that would make me even older. If you double my age, suddenly I'm 56 and the 8th grader is still 14. That doesn't make any sense. When I say that I'm twice the age of an 8th grader, you have to multiply the 8th grader times 2, not me. So, in other words, you're always multiplying the younger person to make their ages equivalent. Okay, so let's go ahead and look at what we get when we solve. So again, the equation here was Tom's age 9 years ago equals 5 times Jerry's age. So we can simplify the expressions by simplifying the left-hand side and using distributive property on the right. I'm going to subtract x from both sides. Again, I can't operate until I have all of my variables gathered onto one side or the other. The reason that I chose to cancel out x is so that 5 minus x, that will be a positive coefficient for the variable. Okay, so I'm left with negative 5 because when I canceled off my x, when I canceled off my x, that negative sign was still there. So negative 5 equals 4x minus 45. Add 45 to both sides because our ultimate goal is to get x along. We're using SADMAG. And then you get 40, and so you divide both sides by 4, which again I can't really show when I'm using my keyboard, so I'll just show it right there. And you get x equals 10. Now that's not the final answer because it says how old is each now. Well, if x is 10, x was Jerry's age, so 10, and then x plus 4 is Tom's age, so 10 and 14. Now let's go back and check this. 9 years ago. Well, 9 years ago, Jerry was just a 1-year-old baby. Okay, so we'll draw him laying down because he's a little baby. And 9 years ago, Tom was a little kid. He was only 5 years old. So it is true, Tom was 5 times older than Jerry. So it works. All right. Thank you for watching. Have a good day.